Hello. The addition rule. With the addition rule, we are looking at, and we've already kind of touched on it with complementary events, and I'll show you that. I'll pull it back in, but we're looking at mutually exclusive or disjoint events or non-disjoint events, and I'll show you that. So we'll begin with mutually exclusive or disjoint events. Disjoint events is just another way to describe mutually exclusive, but you have to understand, and here's just the breakdown. It's just a prefix that means apart, away from, there's a distance to it. Yeah, oftentimes we view the word dis as being meaning not. Joint means combined. So what we're looking at is we're looking at things that are not combined. The other aspect with the addition rule is the word or. Or means to add. And we've looked at that whenever we talked about complementary events. You have the probability of the event occurring, so probability of A, or the probability of it not occurring, not A. And if we add those together, we know that that's my total probability, 1. So a visual representation of disjoint events. I have two separate events occurring, event A and event B. The word or means to add. So whenever I add those, that'll give me everything in my universal set. And again, it was the same premise as this, except the way that I described it was just with one circle. I said, okay, this is event A, so everything that's not inside event A is not A. Two separate events. And the way we look at that is the probability of A or B is equal to the probability of A plus the probability of B. Another way is to view that the probability of A or B, well, it is a union, so we could view it like that. It is the union of the probabilities of A and B. So with disjoint events, they occur separately from each other. They do not affect each other. They are two separate things that can occur. But that's not the way it always is. We have what we call compound events, and what these are non-disjoint events. Again, statistics speak. Really, this is a double negative, correct? Dis means not, so not joint. So I guess that's how you turn around and say that these are joint events. Whereas what we call them in statistics are compound events. You will also see this being used, non-disjoint events. What this means is that there's overlap, there's an intersection between the two events occurring. Things can occur simultaneously. And this is an intersection, and we use the word and to mean intersection. Whenever that occurs is that whenever I count up everything that's inside of A and I count up everything inside of B, some of what is in between those right here in the middle can end up being double counted, because what I count up for everything in the circle of A also goes into B just a little bit, and what I count up for everything inside of B also is a little bit in A. Well, if I just take those two and add them together, I've double counted some values. So what I have to do is I act like they're not even touching A and B, and I just add everything up in A and I add everything up in B. But then I go back and I find out, okay, what's inside of the intersection? Where do they intersect? And I need to subtract that. That way I'm not double counting. So again, we had disjoint events and compound events. I would like to work an example dealing with disjoint events. Two separate events, no intersection, no occurring simultaneously. And here is our problem. Here's an example of disjoint events. What we have is we have different means of transportation and the percent use. Now, what I have written out here is the formula that I gave you for compound events. The reason I've done that is to show you that this works also for disjoint events. and allow me to be able to talk about the intersection again. What is the probability of walking or taking an ATV? Well, the probability of walking is 18%, so that is 0.18. Or, what does or mean? Add, or ATV, 0.22. This is my probability of doing either one of those events. But here I have minus the probability of A and B. Well, there is no A and B in here. They do not intersect anywhere. These are just simply their own events. I guess you could say you could walk next to your ATV, but really either you're walking or you're taking a car or a taxi or the ATV. So there is no intersection, so it's simply minus 0. It has no effect on it. Sum those together. 18 plus 22. Alright, pause the video and see if you can get these two. Alright, so what is the probability of a taxi or a car as your mode of transportation? So a taxi is 0.13 plus a car is 0.47. We can say that's A and that's B. Right here it's 0. There is no intersection. These are disjoint events. So then I add these together. With this one, there are two ways in which to work it. What is the probability of not walking? I could sum up all the probabilities besides walking, so I could say, okay, well that means ATV, and that means taxi, and that means and that means taking my car also. So if I turn around and were to add all those up, see what 0.82, 60, 82. Okay. Or what I could do is I could use this. Look, I could simply say, okay, so not walking, and I could, since this is the not term, I could say, okay, that's not walking. So everything else is walking. Well, I can simply say 1 minus, what's it for walking? I used, what's this called again? Complements. I use complementary events. What is the probability of not walking? Well, I just find what walking is and I subtract it from 1, and that is everything else. That is ATV, taxi, and car. Okay guys, what I will do is I will do a separate video, a continuation of this one, where we work a problem that's a little bit more complicated, dealing with compound events and the addition rule. Please continue to look at the publisher's videos, your textbooks, critically think and structure your problems, work the homework problems as many times as you need so that you can say, I know how to do this. Good luck with your homework.